Good day, folks. In today's class, I'll be talking about the normal distribution graph, and we'll continue picking up from where we left in the last lecture. So I'm going to give you a quick rundown of what we talked about in the last lecture. We talked about this kind of a graph is called a normal distribution graph, and then this line, the middle line, is called this is the mean line. Middle line is the mean line, and then on the left hand side of the mean line, uh, and then to the right hand side, we can figure out the standard deviation. So this is the standard deviation 1 standard deviation, and this is standard deviation 1 on the right hand side. So one standard deviation to the left and to one standard deviation to the right, they both, if I combine them, this will comprise 68% of the data. And then two standard deviation will count for 84% of the data, two standard deviation, 2st, and three standard deviation will count for 99.7% of the data out of 100% data. So means within three standard deviation, it will encompass 99.7% of the data. If there are 1,000 data points, 997 data points will be within the three standard deviations from the mean line. Now, sometimes we wanted to find out what percent of the data is within the 1.5 standard deviation, not within the exact 1, 2, or 3 standard deviation. So 1.5 standard deviation, 1.2 standard deviation, or 0.75 standard deviation. Then what we do for that, we use the z-score. So the formula for the z-score is x minus mu divided by standard deviation. That's the formula we're going to use. Now, how to locate the z-score? Z-score is basically the number of standard deviation. Number of standard deviation. Okay, remember this thing. There are two things when we talk about the standard deviation. One is the amount of standard deviation, and other one is the number of standard deviations. So amount of standard deviation means, if let's say if I go back to the example that mean height of an average Canadian man is 175 centimeter, and if you go one standard deviation to the left and one standard deviation to the right, and the amount of standard deviation is 3 centimeters, so then you will reach to 172 here, and then 180, 178 here. So what does that mean is that this is the amount of standard deviation, 3 centimeter standard deviation amount, and that is sigma. And the number of standard deviation will become 1. So z will become 1, sigma will become, in this case, 3. So hopefully you were able to understand what is the difference between the two terms. Now, if I wanted to find out the number of standard deviations which are in the decimal values, then we can find out easily by using the z-score. So an example, as I took that, let's say, again, I'm gonna recap the previous example which I took. So this was, we said that average height of a Canadian man is 175 centimeter, and at 172 centimeter, I wanted to find out the z-score, and the standard deviation is equal to amount of standard deviation is equal to 3, which I can call it as sigma also. uh, and then I can find the z-score as x bar minus mu divided, not bar, that we'll talk about later on, x minus mu, and divided by sigma. So x value becomes 172. So this is the point which I'm looking for, where 172 lies. 172 minus mean value is 175, and standard deviation is 3. So we went negative 3 over 3, which is one standard deviation to the left. So this point is also called 0. Mean line is called, this is 0. Z-score here is 0, and this will be negative 1. Now, if I wanted to find out the z-score at let's say 166 centimeter, 166. So x value will become somewhere here 166. 166 minus mean value will be still 175 divided by 3. So now if I do the math on my phone, so 166 minus 175 and divided by 3, that comes out to be exactly 3 standard deviation. Okay, actually I should have taken some other number. I accidentally taken a number which end up giving me the whole number. So I'll take 167. So 167 at 167. So I'll erase this. I'll make it 167. Again, why I wrote 167 to the left? Because mean value is 175. So this value will be onto the left of that. So 167 minus 175 and divided by 3. So 167 minus 175, oops, 175 divided by 3, which comes out to be negative 2.66. Z-score is negative 2.66. So you are 2.66 standard deviations away from the mean value. So that is the number of standard deviation. So that's how you find out the z-score. Now your next question is going to be why z-score is helpful for us. So z-score is helpful for us to find out the probability. So the probability graph, it is also given to you in your formula booklet, so I'll highly encourage you to open up your formula booklet and you will be able to find out the probability graph. So a chart, shall I say, there is a chart given to you, one page, and then there is another chart given to you on the other page. So there are two charts given to you. On the left, on the first one, the graph on top is drawn on the left hand side. So this marker is on the left hand side, and on the right hand side, the marker is towards the right hand side, means on the second graph. So these are the two charts you will see, and this one will carry all the values below the mean value. So this is 0, 0, z-score is 0, and here the value, last value you will see is 0.5, means all those probability values of which are in the left hand side, and all those probability value which are on the right hand side you will find on the second table. Now I'm going to take an example actually, and gonna try and show you with the help of chart what does that actually means in detail. Now I'm gonna change the my screen, so please bear with me, and I'm gonna try and open up one of your course schedules. So I'm gonna share whiteboard, again Windows, and share the whole screen. Now it's going well. Now I'm gonna go here, and then I'm gonna go to course homepage, and I will go under the content, and under the content I will be able to find out the formula booklet. So somewhere down here, student resources, I should look into first of all. Oops, I think I'm in the wrong course. Now I should go out of this one. I was into the business math course, so I should go into this one and under content, and then student resources, and then there comes the formula booklet. So this is the formula booklet I'm talking about. All the formulas are given here. You are allowed to carry the formula booklet, and whatever formulas I previously I told you, you can write down on your formula booklet. But if you are writing some extra formulas, please make sure you are taking my approval before using it in the final exam. All right, so this is what I was talking about. So if you see the z-score here, this was the table I was talking about. Z-score starts from 0, and then these all are the probabilities. These these things which are not bold, these numbers which are not bold, the bold numbers are z-scores, and non-bold numbers are not the z-scores. So now if you can recall, the value which I got was from the table. Let me just quickly see. The value which I got was negative 2.66 when I was solving the question. So negative 2.66, how I can locate the probability value, and I'll later on tell you what is the meaning of probability also. First of all, right now I'll tell you how to locate the z-score value. So negative 2.0, this is 2.0. I'll keep going down, and then I will see the negative value here. This is actually negative 2.6. This is negative 2.6. I should go up. So negative 2.6, and then on this side, this is 0.6. So where these two will meet, that will be the probability value I'll take. So this will be 0.0039. This is the value I'm going to consider. This is the value because that is negative 2.66. Negative 2.66. That's how we locate the value. For Z positive values, you're going to locate these values from here. So let's say if I wanted to locate the 2.66, so I'm going to keep going down. 2.66 here, 2.6 is here, this is 2.6, and then correspond to 2.66 I will locate the value. This will become the probability value, 0.9961. So now you're going to ask me, what is the meaning of the probability? So if you see this graph, probability is basically telling you what percentage of the data points which will be covered before that z-score or before that value. So here I was talking about the z value was negative 2.66. So negative 2.66, again I will locate here. Negative 2.66 is somewhere here, that is 0.039. So if I multiply, this is the probability value, so thus it goes from 0 to 1. But if I multiply this by 100, it's going to tell me 0.39% of the data. So 0.39% of the data is below this value. So if I have, let's say, 100 data points, so 0.39 of 100 data points, I should take the 1,000 data points. So 1,000 data points, take the 0.39 of that. So 1,000 multiply by 0.39, that is one second, if I have 1,000 data points, I'm getting 390, but let me just do the calculation if I'm doing the calculation right or not. So 0.0039. So this is, if I multiply it by 100, so 0.39. Yeah, so that will be, let me just do it on the board here. So hopefully you can see the board. Let me quickly see on the screen. So change the screen. So here, so if I have 1,000 data points and the z-score, the probability value correspond to the z-score came out to be correspond to the z-score of negative 2.66 was equal to 0.0039. This was the probability value. Now I wanted to find what does this mean is that this percentage of the data points, 0.0039, if I wanted to convert it into the percentage, it will be 0.39% of the data points will be below the value of the number which we took was z-score for below the value of 167. So if this height was 167 centimeter, so 0.39% of the data points, so 0.39% of 1,000, I wanted to find out what is that. 0.39 divided by 100 multiply by 1,000, that comes out to be 3.9, approximately 4 data points out of 1,000. 4 data points are below 167 centimeter of height. So hopefully you were able to understand what is the meaning of z-score. Now if I will take the z-score of 2.66, so 2.66, so well, actually rather than taking this number, I will take a random number of x. Let's say x value is 183 centimeter. Okay, and I wanted to find out what percentage of population have height less than 183 centimeters. So I'll say 183 minus 175 divided by 3, because standard deviation was 3. This was the mean value. So z-score came out to be for this one is 183 minus 175. Just let me quickly see whether you can see the recording or not. Yes. and then divided by 3, that's going to give me again a perfect 2.66. So actually it gave me 2.67. I must round off the z-score up to 2 decimal places. Remember this thing, z-score must be round off to 2 decimal places, and probability value should be up to 4 decimal places. 4 decimal places for probability value. So please listen this carefully. Z-score 2 decimal places, and z probability should be up to 4 decimal places as given in the chart there. So we got the z value as 2.67. So for z value of 2.67, 2.67, if you're going to go back in the chart and you try to locate it, pause the video and try to locate it, and meanwhile I will also try and locate the value correspond to 2.61. This is a positive number now. So 2.67 will be 0.9962, 0.9962, 0.9962, and that will be means 99%, 99.62%, 99.62% of the data points. I assumed it was 1000 data points, from where I got the average height of 175. So 99.62% of those data points will be less than the than the 100 and what was this, 183 centimeter height. So if let's say this is the population, if it is a Canadian population of 1000, so approximately this percentage of people, which you can say 99.62 divided by 100 multiplied by 1000, and you can say 996.2, approximately 996 people. Let's say if Canadian population is 1000, so 996 people have the height less than 183 centimeter, and only approximately 4 people, their height is above 183 centimeters. So hopefully you were able to understand how do we calculate the z-score and what is the significance, how do we use it. One thing I wanted to tell you, when you are going to the right of the mean value, so this was the mean value, when you went to the right, this was the 2.66. So for 183 centimeter, you found out z-score was 2.67. So this encompass all this region, when I was here, somewhere here. So this was only this region. When I reached here, it encompassed all the regions starting from 0 to that point. So hopefully you were able to understand how to use the z-score. I will see you in another video. Till then, goodbye.